joint. So you missed all that bit, but I do believe somewhere on the YouTube channel I have that again as well, right, from earlier in the year. So you can have if you're following the animation streams, you'll be able to track that down. So this is kind of, again, getting right down to the nitty-gritty basics and just covering it for some of the new students that have just joined. Just trying to organize my windows here. Move my Discord window over here. Okay. Incredibles theme is lasting. All right, so here's what everything I talked about looks like put together, right? So we got our geometry, we got our joints, we got our controls, and eventually it'll be driving a character such as this, right? So we've got our geometry in one group, and we've got our controls in another group, right? And they've actually hidden the joints. Let me see if I can. I don't know if I can load those up because it could be. I don't know if they put it in a group node or a layer. Irregardless, they've hidden the joints, right? So a lot of production-ready character rigs are like that. They'll hide all the joints on. Because really, the only thing that an animator needs to interact with is the geometry so they can see the character and the puppeteering controls, right? It's kind of like that marionette metaphor that I used, except that the strings are hidden. So you just got your controls and then the characters move around, right? You don't really need to see the skeleton. And if you did see the skeleton, it would just make this viewport visually confusing. It's just more visual junk, right? So you can see that all of these controls are kind of connected and hooked up, and the character can kind of move around, right? And do this, whoops. Do this sort of thing, etc., etc. So these are the puppeteering controls, right? And these are the things that we set these keyframes on. So what is a keyframe? Some of you guys seem to be confused as to what that is. A keyframe is just storing of the transform matrix, the translates, the rotates, the scales, etc., at that point in the timeline. So if I'm here at frame 1, I can say, look, I'm going to rotate this a little bit, save that there. So I hit the S key, right? And then as we move forward in time to, let's say, 24 frames, so that would be 24 frames a second. So during 1 second, I want you to move the other way to that position. And I want to save that position, right? So that's really the basics of animation. It doesn't get much more complicated than that. All our lectures without oldest to newest. Okay, so you can see when I play back the timeline, we get that movement, right? So Phil's obviously covered that with the spider bot, but I just thought I'd put a different definition on that. So basically what we're going to try to do, yeah, think of the model like a puppet, definitely. So what we're going to try to do is I'm going to try to take you through some of the basics of setting this character up. Now, how would this be relevant to the games guys? Not just the development, the programmers, but to the game artists as well, right? Because this type of rig, well, let's just say I'm going to walk you through a feature film style rig, kind of, right? With all the bells and whistles, right? So you know exactly what kind of complexity goes into that type of rig. So the game artist might be like, well, we just need to use a very trimmed down human IK basic skeleton or Mixamo type skeleton, which is entirely true. But game skeletons have progressively gotten more complex, and the model they follow are the feature film ones, right? So send me, I'll download it, try it out. Oh, the character model? Yeah, I'll link in the character models in just a second, right? So So one of the things I want to mention is, again, when I was at Electronic Arts, I was working on character rigs for Most Wanted, I think, and I would communicate with. He wasn't the lead rigger; he was higher up, but he was one of our. Well, he worked on an upper floor at Electronic Arts black box called the Worldwide Visualization. He came over from Weta, and he worked on the Hellboy movie, and all the rigging techniques he'd show me were feature film rigging techniques, and then I'd go and I'd try to translate that to real-time skeletons, right? So there's a lot in a game studio, well, in game studios in general, we try to learn quite a bit from a lot of the more advanced techniques used in film and television, etc. So how does this also apply to the programs? Well, one of the things that you may be tasked to do is to sort of help support the character TV or character rigger in terms of either creating tools or just more efficient. Well, the best example I can think of is this one programmer I work with. He was responsible for creating a Verlet integration tool that mimicked real-time plus simulation, et cetera, for characters. So I'd work closely with him, and generally the way I would work is I would simulate the clock inside of 3D Studio Max and say, this is what I'm after. I'd send him my files and my setup. He'd translate it and try to create a real-time version of that clock simulation, something that you guys might be tasked to do, talking to the programmers. Okay, so that's why we're going to cover quite a lot of the relationships that are happening between geometries, controls, etc. Okay, so let me pop into the folder here. I know the animation guys have already got this. Let's see if I can send this over. Whoops, send this over. Just so you have a character to look about. Files are too powerful. This file size too big. Okay. All right. Well, I'll find another way of transferring this over to you guys. Let's just get further and further from puppets. Yeah, I'll send you guys a link where you can grab the character links. Don't worry about that. That's coming. Okay. So, any questions about that so far? All I wanted to touch on today was that relationship between the geometry and the skeleton and the control objects. That's universal. No matter what character you get, they'll have those three ingredients, right? Now, the real trick with sort of character setup is how to create intuitive puppeteering controls that are easy for an animator to sort of grab and to pose out and get working kind of correctly, right? Oh yeah, I'll talk actually a little bit about one other kind of area of rigging to be aware of. Right? Another area of rigging to be sort of cognizant of is this technique of forward kinematics and inverse kinematics, right? What the heck is that, right? So once we get past understanding the relationship between geometry, joints, and controllers, we want to start thinking about how we can apply that to a character, right? Well, the problem with character animation in terms of a bipedal humanoid character has always been the joint hierarchy that deals with limbs, right? So what I'm going to do is I'm going to pop around the right, and let's come in here, and we'll create a locator. Let's move this locator up here, and then duplicate it, down here, duplicate Get it again. Here. Right. Now I'm going to take these locators, middle mouse button, drag them in here, and then parent them together. Now, what is a locator? A locator is a null. A locator is, again, a non-renderable sort of empty object that just carries transform data. Right? Now, I've gone through and I've parented these guys together. But let me switch the background color so we can see that. Yeah, that's good. Right? So I've created this parent-child hierarchy, right? Where I can rotate this and rotate this. And it's basically a joint bin, right? So I can rotate this around. And I've created a bending joint using that hierarchy. Now, if I come in here and I create a joint chain, so skeleton, create joints, right? Right? And I do this, let's take a look at these joints, right? These joints are just locators. That's it. They're no different from the locators here at all. They just carry, translate, rotate data. It's just drawn graphically so it feels like a skeleton. And we can see the hierarchy that's involved in that joint chain, right? One of the big areas of confusion when I first started getting into rigging is we would call these bones, and I thought you could grab the bone. And I thought the animation data was on the bone. It's not. It's stored in these joints, just like in these locators. This connecting bone doesn't really exist. It's just graphical to show us what we're doing, right? Now, here's a little bit about, I guess, a little bit of a trick. So if I come in here and I create a group node, I created an empty one. Let's call it a null, and I'll create a couple more, right? If I come over here, well, actually, let's take this and move it up here. And I'm going to create another group, this guy down here. Here. Oh. Oh, yeah, that's right. Okay, let's back up. Create another null. You'll see what I'm doing in just a sec. That one. Right, so we've got this. I've used group nodes to create the same hierarchy as these locators, as this joint chain. The thing about the group nodes is they actually are invisible. You can't see them. So not only do they work just like a locator, but they occupy less space in memory because the application doesn't have to drive. Why am I showing you this? Because you may find certain rigs that will have these group nodes or these nulls that are empty, and they'll control like part of the arm or something like that. So just so that you guys know what's going on. At the end of the day, the chain of nulls, joint chain, and the locator chain, they all do the same thing. They just hold transformation data to move the geometry. Right? So, any questions about that? No? 9 new messages. Oh, you guys are chatting with the video. Okay. All right. So I'm going to come back up here, and I'm going to grab my locators, joint chain, and nulls, and I'm going to delete all that. Oh, I was going to mention something about FK and IK. So for that, I'm actually going to take those guys, the locators. I'm going to kill those. And let me zero out the rotations on the joints so we can talk about what's next. Now, there are two ways an animator can control this joint chain, right? So one, I can say, all right, let's say this is a leg. I want it to kick up, right? So I'm going to rotate this joint, then rotate this joint as it's getting ready for a kick. Right? Actually, let me, I need one other joint, otherwise the example is not as strong. So let's say I'll draw the leg, and then there's the foot and then the toe, right? That'll be done, right? This might be apples to oranges comparison, but what's the difference with animating using Maya compared to something like Source Filmmaker? I'm just trying to remember. Source Filmmaker was a long time ago. Yes, yeah. So this is another reason why the question being asked is, can you make assets in Maya then animate them with Source Filmmaker? Yes, you absolutely can, right? So it's another reason why you want to keep the geometry separate from the skeleton, separate from the controls, because it makes moving an entire character from one piece of software to another a lot easier. Now, here's the problem, right? Mathematicians or computer graphics scientists could not agree, first of all, on coordinate systems. Let's talk a bit about that, right? So inside of Unreal and inside of 3D Studio Max, the up axis is the Z axis, whereas inside of Maya, Y is up, right? So there are a few different reasons for that. I've heard rumors that Unreal has a Z up axis because it more closely mimics looking down at a level map. So when you're looking down at a level map, you've got the X and the Y as your ground plane, and then Z is you looking down at it, right? So that's why classically any kind of 3D package that deals with game development had a Z up axis. I don't know if I entirely buy that as a story, but it does kind of seem to make sense, right? For all intents and purposes, the Y axis has always been up for me. So there's that. Getting joints that you built in a Y up axis kind of environment into another environment that has Z for an up axis will cause the character to lie suddenly face first onto the ground, right? So there's that. That's one of many niggly little things in terms of translating from one package into another that you have to be wary of. You have to understand the rules of how to prepare the character to move into another package. Once you do get it in another package, like Source Filmmaker, you should be good to go. Again, every CG package on the planet operates characters the same way. Geometry, joints, and controls, right? So you should be okay. There are other niggly bits in terms of how rotations are calculated behind the scenes, but I don't want to get into that just yet. I may mention it later on in this session, right? But you have to be very, very careful. There are two different types of coordinate systems as well. There's left-handed coordinate system and right-handed coordinate system, right? So it has to deal with how you calculate rotational mathematics from your perspective. Very, very similar to looking at things as Y up versus Z up, right? So it's not that the math has changed, not at all. The math is identical. It's just how you approach it is different. So you might have to translate into Source Filmmaker, right? I believe Source Filmmaker is Z up axis and a few other things. I don't know if it's left-handed rotational mechanics or whatever. That's something you have to be aware of. Best thing to do is test it out, right? Give it a shot and see if you can get it working. Okay, so forward kinematics means I'm going to rotate my leg chain forward down the hierarchy, right? So I'm going to move this guy's leg here, and I'm going to move forward and bend it back, and I'm going to move forward, and I'm going to bend the toe back because he's getting ready to kick it, right? So I got to go joint by joint, and then maybe I might curl the toes back a little bit, right? And I'm going joint by joint to animate this, which is not a big deal. I've just gone 1, 2, 3, 4 joints. But can you imagine you got a character with dozens of joints, right? So if I were to, rotate this back, and then let's say he extends his kick, rotate this, rotate this, and I'm traveling forward down the chain, right? I rotate that, and then it's kicking out, right? So that's a lot of rotations to get that joint posed out. Right? There's another solution called inverse kinematics, right? So if I come in here and I go into my skeleton menu, I'm going to come in here and I'm going to create an IK handle. And I select the first joint and the ankle joint, right? And what this now gives me is a control that will inverse rotate. So what it does is it starts with positional data here, rotates this one, and rotates this one back to the joint. But now, instead of rotating each individual joint, I can just go, yeah, kick, right? So two main ways of controlling a character. Forward kinematics, rotating joint by joint, and inverse kinematics, right? Don't ask me which technique is better. Because the fact of the matter is, most modern day rigs will have what's called an IK-FK switch, which will allow you to switch between the two, right? I think on this character, it's this guy here. Is that it? Let's see. Let's finger IK. There's an IK-FK switch in here somewhere. Oh yeah, that's what it is. Where did they set us? Where did they? I can't remember where they hit it. There's usually a toggle that will allow you to switch from FK to IK. But typically in a character will come ready to animate, typically with the arms moving in FK and the legs moving in IK. Right? If I grab this, you can see, woo, there it is, the IK chain. Whee! Right? This has to do a lot with how character animators animate, right? So with walking, all you need to do is place the character's feet, etc. But if I were to come and grab something, an animator would like to put a little bit of an arc and a drag and a snap to the wrist before it grabs something. It's just like this fluid kind of motion, which you can't do with IK. You have to rotate each joint individually to get that sort of expressive pose. So that's kind of why most characters are default FK in the arms and IK in the legs. But nowadays there are IK, FK switches for both, right? Okay, so there's that. I'm going to back this up a bit. And I want to talk about the last thing that you kind of need to be wary of in terms of, well, there's a couple of different things I want to touch on in terms of rigging. It's going to start to get a little bit more complex. So maybe, before I dive into joint properties at a very, very high level, perhaps we should take a 5-minute break, right? I'm just going to go grab a refill of my coffee. It's 10:15. Yeah, that's good. So we can meet back here at 20 past. What do you guys think? Yeah, good. Okay, and in the meantime, think about questions you want to ask if you're still confused, and then just drop them in the Discord. And I'll come back with my coffee, and I'll just answer your questions.